Before jumping into the demo though, I would like to give a high-level overview of the Git workflow, which will help you better following the demo. So let me start by representing 4 fundamental elements in the Git workflow, which are these 4. The workspace, which is your local directory, the index, also called the stage, and we'll see in a minute what the index is. Then we have the local repository. We will also refer to this as head when we explain the different commands and the workflow. And finally, the remote repository. So if you consider a file in your workspace, it can be in 3 possible states. It can be committed, which means that the data, the latest changes to that file, are safely stored here. It could be modified, which is the case of the file being changed and none of these changes being saved to the local repository, so locally modified. Or it can be staged. And staged means that the file is basically part of this index. And what that means, that it's been tagged to be considered in the next commit. And I know that this is not all 100% intuitive, so let's look at that again by considering the actual workflow. And let's see what happens when you issue the different commands in Git. So the first command that you normally run in case you're getting access to a remote repository is the git clone command. And the git clone, followed by the URL for that repository, will create a local copy of the repository in your workspace. And of course, you don't have to do this step if you're creating the repository yourself. The next command that we already saw is the command add. And what the command add does is to add a file that is in the workspace to this index. And we say that after that, the file is staged. So it's marked to be committed, but not yet committed. And here I'm just mentioning this -u option. If you specify the -u option, it will also consider deleted file. But let's not get there for now. We'll talk about that when we do the demo. As I said, if you add the file, it just gets added to this index, but it's not actually committed. So what you need to do is to commit the file. So when you execute git commit, all the files that are staged, that are listed here, their changes will be committed to the local repository. So your files, as I was saying, they can be in 3 states. They will go from the modified state to the stage state when you execute the add, and then from the stage state to the committed state when you perform a git commit. Okay, so at this point, your changes are safely stored in the local repository. Notice that you can also perform these 2 steps at once by executing a commit -a. So if you have a set of modified files and all these files are already part of the repository, so they're already known to the version control system, you can simply execute a commit -a, and what the commit -a command will do, it will stage your file and then commit them all at once. So it's a convenient shortcut. Of course, as I said, this will not work if the file is a new file. So if a file is a new file, you have to manually add it. Otherwise, commit -a will just stage and commit at once. As we discussed when we looked at the difference between centralized and decentralized version control system, we saw that in the case of the decentralized, there is a local repository, which is this one. And then you have to explicitly push your changes to a remote repository. And this is exactly what the git push command does. It pushes your changes that are in the local repository to the remote repository. So at this point, all of your changes will be visible to anyone who has access to the remote repository. Now, let's see the opposite flow. So how does it work when you're actually getting files from the repository instead of committing files to the repository? So the first command I want to mention is the git fetch command. And what the git fetch command does is to get files from the remote repositories to your local repository, but not yet to your working directory. And we will see what is the usefulness of doing this operation, of having the files only in the local repository, but not in your local directory. So what that means, just to make sure that we're on the same page, is that you will not see these files when you work in your local workspace. You will still have your local files here. So this is sort of a physical distinction. In order to get the updated files from the local repositories to your workspace, you have to issue another command, which is the command git merge. Git merge will take the changes in the local repository and get them to your local workspace. So at this point, your files will be updated to what is in the remote repository, or at least to what was on the remote repository at the time of the fetch. Similarly to what happened for the add and commit, there is a shortcut, which is the command git pull. So in case you want to get the changes directly to your workspace with a single command, you can issue a git pull command, and what will happen is that the changes will get collected from the remote repository and they will go to your local repository and to your workspace at once. So this has the same effect as performing a git fetch and a git merge. So if we can do everything in one command, why might we want to fetch and merge as two separate operations? So one of the reasons is because this allows us to compare files before we actually get the latest version of the files. In particular, I can run the command git diff head to get the difference between my local files, the files in my working directory, and the files in my local repository. So what I can do, I can fetch the files from the remote repository, and once I fetch these files, I can run a git diff head and check what the differences are. And based on the differences, decide whether I want to merge or not. So while we're talking about git diff, there's something else that you can use with the diff command. So what you can do, you can run git diff without further specifying head. In this case, what the command tell you is the difference between the files that you have in your workspace and the ones that are staged for commit. So basically, what it will be telling you is what you could still add to the stage for the further commit and that you haven't already. So what local changes will not make it to the next commit, basically. And this you can use, for example, as a sanity check before doing a commit to make sure that all the local changes that you have and that you want to commit are actually staged and therefore will be considered. So now we will cover all of the commands that we saw here in our practical demo. But please feel free to refer back to this GIT workflow to get a kind of a high-level vision, or maybe you want to keep it next to you, because this really gives you the overall structure and the overall view of what happens when you run the different commands. And it also helps you visualize the different elements that are relevant when you're using Git. So the workspace, once more, the index or stage, the local repository, and the remote repository.